A warm welcome to this session on Prepare Bill of Material for a 20 kilowatt solar photovoltaic installation. At the end of this session, you will be able to select components for 20 kilowatt solar photovoltaic after sizing. Draw single line diagram for 20 kilowatt solar photovoltaic system. Tools and equipments required: paper, pencil, eraser, scale, AC combiner, hammer, screwdriver set, crimping tool 3 mm to 16 mm, DE double-ended spanner set 6 mm to 15 mm, multimeter, product profiles of solar panels, batteries, array junction box, charge controller, DC disconnectors, AC disconnector, inverter. Calculation for sizing of components. Sample calculation. The bulb rating is 100 watts such that 5 loads are there and runs 6 hours. Power consumption per load is equal to 100 watts multiplied by 6 hours is equal to 600 watt hours. Then the power consumption for 5 loads is equal to 600 watt hour multiplied by 5 number of loads, which is equal to 3000 watt hour. The total power consumed by above loads are 18,280 watt hours. If converts into units, 18,280 divided by 1000 is equal to 18.28 units, because 1000 watt hours or 1 kilowatt hour is equal to 1 unit. Sizing of solar panel. For a 20 kilowatt solar photovoltaic system, sizing depends upon few components. Those are solar panels, inverter, battery bank. For the plant capacity of 20 kilowatt, the solar panels are connected to get the resultant voltage is maximum voltage Vm multiplied by number of panels used. System voltage is a DC value in volts selected as working voltage common to all DC components in a solar photovoltaic system so that mismatch of level of voltages is avoided. Recommended value of the system voltage for 20 kilowatt capacity power plant is 24 volts. For a 20 kilowatt solar photovoltaic plant, minimum 20,000 watt to be generated by solar array. This can be achieved by grouping 80 number of solar panels, each having capacity of watt power WP is equal to 250 watt. Solar panel rating is maximum voltage Vn is equal to 30 volts DC and the maximum current Im is 8 amperes, that gives the 240 watt power WP, that is approximate matching to the watt power WP of the 250 watts. To achieve the given 20 kilowatt power, the voltage developed by each panel string is 30 volts multiplied by 80 number of panels is equal to 2400 volts. The power produced is 2400 volts multiplied by 10 amperes is equal to 24,000 watt. To get the 20 kilowatt power, 80 panels are required and 4 strings are made, each string having with 20 panels, and each can produce 6000 watt power. That is 20 multiplied by 30 multiplied by 10 is equal to 6000 watt. Selection and sizing of inverter. We can select the inverter based on capacity, technology, allowed power load, batteries required, solar panel voltage, solar panel current. Inverter specification are 2 channels, DC input range, AC output, watt or kilowatt, volt ampere or kilovolt ampere, power factor For power factor, PF is equal to 0.8, 1000 watt is equal to 1250 volts ampere. Waveform, sinusoidal, square wave, quasi-sine wave. Inverter output voltage is 400 volts AC, 50 Hz, 3 phase, 2 channels. The power output is 20 kilowatt. DC input for inverter is 450 volts to 850 volts DC, 30 amperes, 2 channels, each 10 kilowatt. Sizing of batteries. For deciding on battery size, we have to decide on system voltage first. System voltage is considered as 24 volts. The unit size of battery is 12 volts. Then, according to the value preferred based on capacity of the system, we can group the batteries in series, parallel or series parallel combinations. The inverter input voltage is 450 volts to 850 volts DC, 30 amperes maximum. So, battery bank voltage is 300 volts, 20 amperes DC per channel. Each battery voltage is 12 volts DC and 20 ampere hour. So, 12 volts multiplied by 25 is 300 volts. To get 300 volts DC, the number of batteries required are 300 divided by 12 is 25 number per one channel. Like that, 4 channels are required. For 20 kilowatt power, 4 battery banks with total of 100 number of batteries are required. They are connected in series to produce the output voltage of 300 volts DC per channel. The total power rating is 20 amperes into 300 volts is equal to 6000 watts per battery bank. For 4 battery banks, the power rating is 4 multiplied by 6000 watts is equal to 24,000 watts. Select components for a 20 kilowatt solar photovoltaic installation. For a 20 kilowatt solar photovoltaic plant, say minimum 20,000 watts to be generated by solar array. Then it can be achieved by grouping of 80 number of solar panels, each having capacity of watt power 250 watts, can be connected in multiple ways. That is option 1. Now let us connect 4 number of 5 kilowatt solar photovoltaic plants and combine the AC outputs of all to get 20 kilowatt AC output with the help of AC combiner. The inverter must be 20 kilowatt. Note, in 3D, show the 20 kilowatt line diagram using 4 5 kilowatt solar photovoltaics. Select components for a 20 kilowatt solar photovoltaic installation. Option 2. The solar array can have 4 string paths of 20 panels each in series and all connected in parallel to get 20,000 watts array output with string voltage 300 volts but single array junction box output 300 volts 10 amperes. We have maximum voltage Vm is equal to 30 volts. Maximum current Im is equal to 10 amperes. Battery bank output must be VDC output. In order to get this output, connect 25 batteries each of 12 volts in series. Total of 100 batteries with 4 branches are required. Then, solar DC input range for PCU or inverter should be 300 volts to 450 volts DC at 30 amperes each channel. The power generated is 400 volts, 50 Hz, 3-phase, 20 kilowatt. Single line diagram. To develop the SLD for 20 kilowatt solar photovoltaic plant. SLD is a single line diagram to represent the electrical components and paths to easily understand the implementation of 20 kilowatt solar photovoltaic system. Let us show how different components are connected. 20 solar panels, each of 250 watt power and 30 Vm maximum voltage, 10 Im maximum current are connected in series as one string. Two such strings are connected to array junction box 1 through DC disconnector 1. 20 solar panels, each of 250 watt power and 30 maximum voltage Vm, 10 maximum current Im are connected in series as one string. Two such strings are connected to array junction box 2 through DC disconnector 2. Total of 80 solar panels are used. The output of array junction box would be 300 volts at 30 amperes. Array junction boxes are connected to the charge controller through DC disconnector. The charge controller is connected to the battery bank through a DC disconnector. Batteries are connected such that set of 100 batteries are connected in series. In the battery bank, batteries are connected in series as required by the inverter voltage input through DC disconnector, that is 450 to 850 volts DC, 30 amperes multiplied by 2 inputs. The inverter produces an output power of 400 volts, 50 Hz, 3-phase AC power by taking DC power from the battery banks. The inverter output power will be given to the AC loads through AC combiner and AC disconnector. For on-grid solar photovoltaic system, an additional 2 blocks for normal power supply of 400 volts AC, 50 Hz and charge controller are used to recharge the battery bank when the solar power is not sufficient to charge the batteries. Bill of materials. The individual components required to build a 20 kilowatt solar photovoltaic installation system are the following. Number of solar panels 80. Inverter with 4 channel inputs 1. Battery bank 100. Array junction box 2. Charge controller 4. DC disconnectors 8. AC disconnector 2. Suitable cables as required. AC combiner with 4 channel input 1. Solar cable specifications are given below. MC4 connector specifications are given below. Recap. In this session, we have learnt how to select components for 20 kilowatt solar photovoltaic after sizing, how to draw single line diagram for 20 kilowatt solar photovoltaic system. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.